going. Okay, so just real quick, going to go over the law of signs. Let's just derive this real quick. I got our two triangles there. All right, sine of A. Nick, what's it equal?
H over C.
H over C, opposite over hypotenuse. We got a right triangle. Sine of A equals H over C. Kaya, what's the sine of angle C going to equal?
H over A.
H over A. Okay, opposite over hypotenuse, the hypotenuse of the green triangle, H over A. All right, get H by itself for both of them, which means on that left-hand side, I'm going to multiply both of them by C. So you get C times the sine of A equals H. And then I get A times the sine of C equals H. Well, you don't see any H in the law of cosine or law of sines, do you? Well, what can we do? They both equal H, set them equal to each other. Kind of, or you can view it as substitution or just setting them equal to each other. So I got C times the sine of A equals, because you're going to take that in for H, A times the sine of C. Well, if you look at the law of sines, it just has the sine of the angle at the top in the numerator. So we got to get rid of that, the C on the left-hand side and the A on the right-hand side. How can I do that? I can do it in one shot. Divide them both over. Yeah, we can do that. And when you do that, if I divide by A, I got to divide this by A. I got to divide that one by C. I got to divide that one by C. So I'm just going to divide by AC in one step. And when I do that, the C's cancel for on the left side, the A's cancel on the right side, and I got sine of A over A equals sine of C over C. And there you go. There's your law of sines. And you can just rearrange it and put in angle B. But I think it's good to see that and just to understand that. It works for a right triangle, but it works for any triangle. Okay, we can now use this for non-right triangles. Got it? All right, let's take a look at what this means. All right, this is number one. You see where you got number two? Do not put anything from number one on number two. That's a totally separate problem. Everybody in the first class kept putting their answers down there. Just keep everything above there. All right, you remember from geometry, angle, angle, side, and angle, side, angle. What the heck does that mean? How are they different? Okay, basically just what you know. For angle, angle, side, if I know one angle, if I know the side between the two angles, we call this angle, side angle. Okay? That's called an included side. All right, well, how would angle, angle, side be different? Okay, angle, angle, or how would it look? So I would know two angles, but the side would have to be something not between them. Okay, that would be angle, angle, side. Okay. Now, what is this one here? Now, I don't have it labeled. So I'm going to kind of get as close as I can. Let's call that A. Let's call that B. Let's call this C. Angle B is 74 degrees. Angle A is 62 degrees. Side C is 14. You just can't throw 14 anywhere. It has to be across from angle C. So what type of figure do we have? We have angle, side, angle. All right, now for all of these, you got to find any missing angles and any missing sides. Okay, so anything that is not known. So I got to find A, side A. I got to find side B, and I got to find angle C. Well, angle C is not that hard to find. Okay, because the three angles have to add up to 360.
180. 180.
180.
I heard 180.
I'm sure you did. So I take 180 minus 62 minus 74. 44 degrees. So 44 degrees, angle C. All right, I need to find side A, I need to find side B. One of the huge things about doing these is you want to find it without using any, like a rounded off value. Now using angle 44, or using the 44 degrees is fine because it's not rounded off. That's exact from what we were given. So you will not deal with any round off there. All right, let's look at side A. How can I find side A? From the information we have. Okay, so we got to set up a proportion using law of sines. Sine of an angle over a side equals the sine of an angle over a side. You need to know 3 of the 4 parts and find the missing one. So let's just say I'm looking for A to begin with. What is the only side that I know the angle across from it? C. So I got to use that. So I got to use sine of C over side C equals sine of A over side A. And you got to know 3 to 4 parts. Well, more often than not, you're just going to write it in with the values, which is fine. But sine of 44 over, what do I got? 14 equals sine of 62 over A. Okay, it's really a proportion, cross multiply. Round to the nearest 10. Round to the nearest 10. So you get A times the sine of 44 equals 14 times sine of 62 degrees. Divide by sine of 44. Make sure you're entering everything in there correctly. Okay. And then Brittany Jordan, let me know what you get.
17.8.
17.8? All right. 17.8. From geometry, remember in a triangle, the relationship between the sides and the angle. The biggest side has to be across from the biggest angle. The smallest side has to be across from the smallest angle. 44 degrees is the smallest angle. 14 is across from it. Since that's 62 degrees, that has to be bigger than 14. 17.8, at least we feel good about that. Now the last side has to be bigger than 17.8 because 74 is the biggest angle. Okay, can we solve for side B without using that 17.8? And that's what you want to do. Do not use that rounded off value, and do not round off within your work until the last step. So just enter everything in, and then keep it in your calculator until the end. I can reuse the 44 and the 14. Sine of 44 degrees over 14 equals sine of 74 degrees over B. Cross multiply. Divide by sine of 44. And so we get 14 times sine of 74. Yes, you can type it all at once, but it never hurts to kind of go, here's your numerator, divided by sine of 44, 19.4. So I get B is 19.4, and that stays in line with the fact that that's the biggest, so it's going to be inches as well. Oops. I should be labeling this. Inches. The biggest angle needs to be across from the biggest side, so that kind of keeps us in line there. All right, that's number 1. Number 2, on your sheet, fill in those values. Fill in those values. And then I have a figure drawn, and so you want to make it somewhat accurate. I'll label B this angle here. C, A. B is 112 degrees. C is 32 degrees, and B, side B, is 21 miles. And side A and side C is what we're looking for, along with angle A. All right, this is angle, side. Law of sines works perfect with either of those situations. All right, find your missing angle. Oh, what is it? 112 and 32, 144. Is it 36?
Yeah.
Okay. So angle A equals 36 degrees. All right, now I need to find side A. You got to use the 36 degrees because you're missing the other two angles. So sine of 36 over side A, and then I got to use the B, the 112, and the 21. Sine of 112 over 21, and then sine, I'm just going to write them both down now. Sine of 36 over, nope, I need to find C, so use the angle C. Sine of 32 degrees over C equals sine of 112 over 21. All right, figure out what you get for both of those. Now 32 and 36 are pretty close together, but the sine across from 36 should be a little bit larger, or it has to be a little bit larger when you get through. Logan Miller, you got either one? No. Well, you doing it mentally?
I was trying.
How'd that work? How was that working?
I almost had it. He's a human calculator.
Should be.
A is 13.3.
A is 13.3. Joe, what do you got for C?
12.0. 12 flat. Yeah, 12 flat.
12 flat. You should put the point out because it does tell us something says it's not exactly 12 and it did round off. Okay, so a lot of times people will just put 12. I think that's a little bit misleading because it does not come out to exactly 12 or 12 flat. It's 12.0. All right, that is A and C for those. All right, take a look at number 3. It says to find the distance AB across a river. All right, now these are one of the harder ones because you got to figure out how to draw it. Okay, you got to figure out how to draw it. That's part of what we need to go over. All right, we want to find the distance AB. A distance BC of 1,056 meters is laid off on one side of the river. So B and C have to be on the same side. If it is found that angle B is 105.4 degrees and angle C is 17.5. Find side AB. All right, now there's my river. Okay. I am going to label point B right here. And I'm going to label point C right here. That's 1,056. All right, so you're going to have to think about where A is. Since angle B is 105.4 degrees, you don't want to draw A straight across. You need to draw A at a little bit of an angle. Okay. And then that's going to be, what do we say, 105.4. Okay, angle C, 17.5 degrees, and I'm going to call AB X. It doesn't matter, just some variable. All right, so there's your scenario. All you have to do is find the missing X in this case. I do need to know angle A, 180. What is that? 122.9. So what is it? 57.1? Yes. 57.1. 57.1. Sine of 57.1 over 1,056 equals sine of 17.5 over x. So x times the sine of 57.1 equals 1,056 times the sine of 17.5 divided by the sine of 57.1. Nearest meter is fine. Nearest meter. Tyler, you got it?
378.
378? Yeah. So 378 meters. All right, make sense? All right, I'm just gonna walk you through this back part. We're not actually gonna do any of the, we're just going through that top part with the bearings, and then we're gonna call it a week.
Yes.
A lot of times, bearing is used to describe how like a ship is traveling or a plane. And so you at least need to be familiar with it to be able to draw the scenario out. So a bearing is the measure of an acute angle from due north or south. So this is how you will read, or it will be given to you. North, 40 degrees east. Well, if something is sighted or traveling, you look straight north from 0, 0, and you go 40 degrees to the east. That's how you get quadrant 1, okay? Northeast. Okay, what would be quadrant 2? It would have to be northwest. Okay, so north 60 degrees west would put us traveling in quadrant 2. So you travel in quadrant 3 and 4, you're going south. So south 30 degrees west would be quadrant 3, and south 75 degrees east would be quadrant 4. All right, so, and then if you're just traveling straight east or straight west, okay, or due north or due south. All right, let's just look at this. I'm not going to go through it, but this is kind of how something that you need to be familiar with. A boat sailing due north at a rate of 10 miles per hour records the bearing of a lighthouse as north 10 degrees east. So where's that lighthouse at?
Yeah,
if you want to think in terms of quadrant, okay, in terms of quadrant, so let's just pretend that you are right here at the origin and you see it north 10 degrees east. So it's somewhere out here, and that angle is going to be 10 degrees. All right, we'll finish this sometime. Not sure when. Not sure when or how. But listen for me Monday.